The last part of this section is going to be dealing with adding and subtracting radicals as well as multiplying them and rationalizing the denominator some more. So I just am going to throw out a couple examples of each scenario, and if you have any questions as you work through, make sure you ask me in class. The first thing to do is to add or subtract radicals. So in order to do that, the key here is that you have radicals that have the same radicand. And remember, the radicand is the number underneath the radical sign. If you look at this first example, square root of 98 minus 2 times the square root of 32. You could type that in your calculator, but without a calculator, you could not combine these and subtract them because the numbers underneath don't match. So when you are doing these adding and subtracting problems, you have to reduce them down as much as possible so that the radicals match. And to do that, we have to practice reducing our radicals. So remember, when we reduce our square root or any root, we have to break it into two roots that can be multiplied to get the number, where one of them can be reduced all the way. The easiest way to do that is to think of your factors of 98. So to do that, we could think of 49 times 2 would get us 48. And if I use 49 and 2, I can tell that the square root of 49 would reduce to 7. So I'd be left with 7 root 2. So I broke it down, one of them had to be reducible, and then we simplify. Same thing works for the square root of 32. I can break this down into the square root of 16 times the square root of 2. I also still have a 2 out in front here I have to bring down. And if I reduce that, I get 2 times 4, because square root of 16 is 4, and then times the square root of 2. So here that gives me 8 root 2, and then remember there was a minus sign in between them. And because I have reduced them all the way, notice that I have the square root of 2 in both of them. Now, because I've reduced it to the same radicand, I can combine like terms. When you add or subtract radicals, all you have to do is add or subtract the number in front. You do not change the square root part. It's kind of like if I said, what's 5x minus 4x? You would get just a 1x. So you don't change the variable, but you do change the number in front. So same concept. 7 minus 8 is -1, and then we're going to leave the square root of 2 the same. And there's your final answer. So anytime you're adding or subtracting, reduce the radicals, then you can add or subtract the numbers in front. And that doesn't work just for square roots. It can be for cube roots, fifth roots, eighth roots. You just have to be able to reduce it down regardless of the index. All right, the one I have right below here, it's another square root one, but I want you to go ahead and try that, and then you can always check your answer with me in class to see if you've done it correctly. All right, so pause your video, try that, and then we can move on. The next part we're going to be looking at is basically just multiplication. So if you notice here, we've got two binomials that I want us to multiply, and it's just FOIL. All right. We're just stepping up our multiplication skills a little bit by dealing with the radicals. So I'm just going to FOIL first, outside, inside, last, and I'm going to show you that process, and then we're going to talk about how it's different when we have a radical in it. So first would be the 6 root 3 times 2 root 5. Now remember that when we're multiplying, we can multiply the square roots. As long as they're both square roots or both cube roots, we can combine them. So the numbers in front, 6 times 2 is 12, and then root 3 times the root 5 is root 15. So there's the first part. Then I'm going to do the outside 2. So multiply those together, 6 root 3 times 4 root 2. That's going to get us plus a 24 root 6. Okay, then I'm going to do the inside 2. So we'd have -5 times 2 root 5. That's going to get us -10 root 5. And then lastly, I'll do that in blue, we'd have the last. So -5 times 4 root 2. So -5 times 4 root 2. When I multiply those together, we get -20 root 2. Notice that if it doesn't have a root with it, you only multiply it by the number in front of the root. And now I've got all of these here. None of them have the same root. You'd want to see if you could combine any of them or reduce any of them, but because you cannot, you would leave this as your final answer. So the key on these multiplication problems is to FOIL, and then of course after you FOILed, see if you can reduce anything or combine like terms. But like I said, this is the final answer. Not very pretty, but we would be done. All right, if you have any questions on FOIL or multiplying the roots, please let me know. And then our last example is where we deal with conjugates. Now, we talked about conjugates in the last semester. Remember, these are just binomials with opposite signs. We really use these when we talked about imaginary numbers. So 5 plus I, its conjugate would have been 5 minus I. The same thing works for radicals. So an imaginary number always has a positive and a negative. They travel in pairs. Same thing with a radical. So it's going to always have a minus and a plus. Remember from the earlier video, we said we cannot have radicals in the denominator. Well, here we have 2 over root 5 minus 1. We can't leave it as is because we've got the radical in the denominator. That's not easily simplified. So we're going to use conjugates in order to get rid of the radical underneath. And to do that, we're going to multiply the top and bottom by the conjugate of whatever the denominator is. So the conjugate of the root 5 minus 1 would be the root 5 plus 1. And you have to do that both on the top and the bottom, right? And now it's just FOIL again. So on the top, we're going to distribute. So 2 times root 5 is 2 root 5. And then 2 times 1 is positive 2. So there's the top. And then on the bottom, we could FOIL out. So root 5 times root 5 is going to be the square root of 25. Then root 5 times 1 is positive 1 root 5. Negative 1 times root 5 would be negative 1 root 5. And then negative 1 times 1 is just a negative 1. And now we can go ahead and simplify as much as possible. The top cannot be simplified because they don't have the same square roots. And then the bottom, if you notice, the 1 root 5 and the negative 1 root 5, those can be combined because they have the same root, and 1 and negative 1 will cancel, so those will go away. Do that in red. So those cancel, and then that's going to leave us with root 25 plus 1. Notice that square root of 25, we should know that answer. It's just 5. So this becomes a 5 plus 1, which would get us 6. So in the denominator, we're left with 6, and on the top, we're left with 2 root 5 plus 2. Now, the one thing you should be able to do is look at your terms here, and if they can be reduced by something, you always want to reduce. So the easiest thing I could do here is reduce everything by 2, and that's going to leave us with a 1 root 5 plus 1 over 3. Now, if you're going to reduce something, you have to be able to reduce it out of everything. You can't just reduce out of 2 numbers. It has to come out of all of them in order to work. So be very careful when you're reducing your final answers to make sure you take it out of all parts of your answer, not just 1 or 2 parts. All right, so conjugates, you need to know what those are and how to use them. Make sure you look back and know how to FOIL with radicals, as well as when you can add and subtract radicals. And if you have any questions, make yourself a note and then go ahead and ask me in class. But that's it for this section. Thanks for listening.